All right, let's get started here with 1, 2. We're going to solve equations, and we're going to do that two ways. We're going to use a graphing calculator. That's our graphing utility. Whenever you see that in the textbook, remember that graphing utility is just what the book is using to say graphing calculator. And we're going to do linear and rational equations. We'll do those algebraically as well as with a graphing calculator. So, a couple different ways to solve our equations. Some of this is going to be review. Some of this is going to be new. So let's start with something that may be new, because if you haven't used the TI-83 or 84s before, you probably haven't done it this way. But let's solve equations using our graphing utilities. So we're going to be given an equation like this. X cubed plus x minus 1 equals 0. All right, so an equation like this, we can assume that if it equals 0, we can say, all right, equals y, because that's going to be finding the places where this crosses the x-axis. So let's go ahead and put this into our graphing calculator. We're going to go to our graphing calculator, hit our y equal. Now, one thing that's really important, make sure that none of your plot ones are turned on here when you're dealing with the y equals. Okay, some of you may have had problems in the last video, and it may have been stemming from the fact that these were turned on. Some other settings were going on in your calculator creating errors that you didn't really know about because everything in your y1 or your y2 was entered perfectly, but you were still getting errors. So make sure the plot ones are all turned off. When I mean turned off, highlighted like that. And to get that off, you can just go up to it, pressing the up arrow, and hit enter. We come back off of it, and it's not highlighted anymore. All right, so let's start here. X cubed, so x caret 3 for x cubed, plus x minus 1. That's our graph. Remember, we're going to go to our window, make sure we have a good starting window, negative 10 to 10, and then we're going to graph. And here we go. See, it turns over right there. And we're looking for the place where the y is 0. So that's right here. Where does it cross the x-axis? That's our 0. All right? So I'm going to zoom in a little bit more so we can see it better. This will be the first time we've used the zoom box. So the very first one, number 1. Hitting enter here. You'll see right here, it's kind of hard to see this flashing cursors on my origin. What I'm going to do is I'm going to move this up and maybe over just so we can see it. And I'm going to hit enter. And what that does is it creates the top left corner of a box, a bounding box. And I'm going to move down and to the right until I create a rectangle that encapsulates, that encloses the point I want to look at. And when I hit enter, we're going to zoom into this rectangle. So it's a nice way to zoom into exactly where you want to go. I hit enter. We're closing in. All right, so right there clearly is where we cross the x-axis. That's our 0. So that's going to be the solution to this equation. All right, how do we make the calculator solve this for us? We're going to calculate. So second trace to get to calculate. We're going to calculate the 0. Right? We're equaling 0, so we want to figure out the 0. So I can go down and hit enter. I can also just hit number 2 for the 0. All right, we did this in last class. Let's do it one more time. We need to go to the left of our 0, hit enter, go to the right of our 0, hit enter, and then guess. We're going to jump right on top of it, close as we can, hit enter, and there we go. Our 0 is 0.6823278. And so we need to, if we go back to the PowerPoint here, round to 2 decimal places, 0.68. So our answer here is x equals 0.68. Now, one thing to keep in mind here is that you can have multiple answers for x if this had crossed the x-axis in more than one place, but it didn't. It only crossed here, so we only have one solution. All right, so with what we just learned there, see if you can try problem 17 in the textbook. All right, so let's go ahead and solve one when we don't have 0 on one side. Now, two ways to do this. We could move this equation around and get x squared minus 3x minus 3 equals 0 and solve it the way we just did. No problem with that. We'll get the solution. But we can just use each of the sides of the equation and set them equal to y. Now, since we have two equations now, two sides of the original equation, we're going to have two different y's, a y1 and a y2. So the left side became y1, and the right side became y2. So let's go ahead back to our graphing calculator and go back to our y equals. And for y1, we'll plug in x squared minus 2 minus 2. And for your y2, we're going to have 3x plus 1. Let's get ourselves back to a good window. So negative 10 to 10. And negative 10 to 10 for our y mins and maxes. And let's go ahead and graph and see what we've got. All right, so we're looking for the places where this, which is our parabola, the x squared, equals this. The 3x is our straight line. So where do those two places intersect? And it looks like we cross in two different places, but one of them we can't really see. So let's go ahead and use our old zoom fit, which is 0. Okay, it'll redraw this. It crosses once and twice. And so now we're going to go in there with a zoom box, and draw our box around the area. There's my cursor. That encloses both of the intersections. Okay, just so we can get a nice view on things. And so I'll drag this over here until it's enclosing the second intersection. I've got a nice viewing rectangle. I'll hit enter, and it'll redraw it for me. And we can see, all right, there's going to be one, and there's our second solution. So let's go ahead and calculate our answer. Second trace to calculate. Now this time we're not looking for the 0, right? If we look back at the graph, we didn't set this equal to 0. So we're not doing the 0. Instead, we're intersecting. So now we're calculating the intersection. All right, so we go 5. So the first curve, what it does is it says, and this is just kind of a check. It's usually going to be right. y1, is y1 the x squared minus 2? Is that this parabola? It is, so we're just going to hit enter. Is this one your second curve? It is, so we're just going to hit enter. All right, and what's our guess? Let's go over here to where it crosses. So we don't have to do a left bound, right bound here, just a guess on where we think they cross. And we say negative 0.79 for our x. So x equals negative 0.79. And remember, in the original problem, there's no y's at all. So even though in the graphing calculator we have a y value, we're not solving for the y. We're solving for the x. So we want the x value here. Let's go back in and solve the other one, because there's a second place where we intersect. So we'll calculate again. Our intersection, I can just hit 5. And we'll say, all right, our first curve, it's still this parabola, so I'll hit enter. Our second curve is still this straight line, so I'll hit enter. And now where's our guess? Scroll up here. It looks like right about there. I'll hit enter. And 3.79 is our other answer. X equals 3.79. Now, let's go ahead and check it using the first method we learned and see if using the 0 method will get us the same answers. So, graphing calculator, I'll go back here. I'm going to clear this out. Clear the other one out. We're going to use the other method, x squared minus 3x minus 3. And we're going to head and give ourselves a good window here again, negative 10 to 10, negative 10 to 10. And we'll graph. And it crosses in two places. All right, so already we know we're in good shape, because we know one of our answers needs to be negative. Looks like that's working. One of our answers needs to be positive. Looks like that's working. But let's go ahead and check just to be sure. We'll calculate our zeros. Number 2. Let's go to the left of the first 0. Let's go to the right of the first 0. And let's jump on the guess. And look at that, negative 0.79. If we calculate the other one, our 0, we'll say left bound. A little bit to the left, a little bit to the right, and where's our guess? Boom, 3.79. We got a winner. So, use our second method here. Try to use the intersection method to solve problem 19. Okay, so here's a nice summary of what we just did here. All right, if you want to pause the video and get this down, this takes you step by step to what I was just talking about to solve using the zeros and solve using the intersect feature of your graphing calculator. All right, so this is another slide in the book here. This is a refresher on how to solve algebraically. So here, this was the summary for solving graphically using the graphing calculator. Here's our summary for how we're going to solve algebraically. So just a couple tips here. We can always switch the order, switch the sides of your equation. If 3 equals x, we can switch it and make it x equals 3. All right, we can always collect like terms. So if we have x plus 2 plus 6 on one side, let's go ahead and make it x plus 8. And we can distribute too. So 2x plus 3x is 5x. This is not 1 over here. Remember, it's 3 times 1. You get 3. Remember, we can always add or subtract the same thing on both sides. So if we have a minus 5, let's do a plus 5 to cancel it out. But if we do it on one side, we need to do it on the other. Okay, so these are some basic algebra steps. Just a reminder here, this is something that sometimes we trip up on. If we have a denominator, we can multiply both sides by the denominator and they'll cancel out. And then lastly here, if you can factor and the other side is 0, then both terms, or all your terms if you have more than 2, get to be set equal to 0. X equals 0 and x minus 3 equals 0. So a nice handy little list of tips. You might want to pause the video and get that down. All right, but once you have that, take a look at problem 9 in the textbook. All right, so let's jump into our second objective here, solving linear equations, and we're going to do these algebraically. Now, you absolutely can do these graphically, but with the tips with the methods we've already done. But here we're going to walk through how we do them algebraically. So, if we have ax plus b equals 0, then we have a linear equation in one variable. We just have x. A and b are going to be real numbers. So, when we say linear equation in one variable, we're trying to make it look something like this. And then our job is to figure out what x is, get x by itself. Let's take a look here. So, first example here, we're going to have to follow the tip that said simplify both sides. So we're going to distribute. This is 2x minus 2. This is negative 3x minus 6. Now we can always do the same thing to both sides, so let's get rid of our 2 first. So we'll have 2x equals negative 3x minus 4. Let's get rid of our 3x, the negative 3x, by adding 3x. And so we'll get 5x equal to negative 4. And then we'll divide both sides by 5 and say x equals negative 4/5. Or you could turn it into a decimal and say x equals negative 0.8. Okay? We could always go back in and check this. So 2, negative 4/5 minus 1. If we plug that in, that's going to be 2 times negative 1 could be turned into 5 over 5. So that's negative 9/5. And so now we have negative 18/5. Let's check the other side. Negative 3 n times negative 4 over 5 plus 2. And remember, 2 could be written as 10 over 5. So plus 10 over 5. And so we have negative 3 times negative, positive. 10 minus 4 is positive 6 over 5. If we were to multiply those together, we get negative 18 over 5. Do both sides equal each other? They do. And so we've been able to check and know that x equals negative 4/5 is the answer. So, see if you can solve 35 the exact same way. Okay, so now what if we have some multiplying going on? Same thing here. We're going to be able to distribute both sides. And in distributing this equation, we're going to have to FOIL. So we've got 2x squared. We've got plus 10x. We've got minus x, and we've got minus 5, which simplifies to 2x squared plus 9x minus 5. Over on the other side, we have 2x squared. We have plus 3x. We have plus 4x. And we have plus 6, which is 2x squared plus 7x plus 6. All right, so let's go ahead and see if we can clean this up. We're going to subtract 2x squared from both sides. And so now we have 9x minus 5 equal to 7x plus 6. And let's go ahead and add 5 to both sides. 9x equals 7x plus 11. And let's subtract from both sides and get 2x equals 11, so that when we divide, x equals 11 over 2, which is equal to 5.5. Either of those answers perfectly acceptable. Okay? And we can plug this back in to check. We can also check this graphically by plugging this into our y1 and our y2 and seeing where they intersect. All right, so let's use the same methods and see if we can do problem 55. All right, so now what about rational equations? First of all, what is a rational equation? Rational equation is when we have fractions going on, right? And then we have an equal sign making it an equation. So what do we need to do on this problem? When we have fractions on both sides, we don't want to have fractions, so we're going to get rid of them right off the bat. So what we're going to do is we're going to identify all the different denominators. There's an x minus 1, there's an x plus 2, and then these are repeats, x minus 1 and x plus 2. So here's what we're going to do. We're going to multiply every single term, the 2 over x minus 1, by both of the denominators, times x minus 1 times x plus 2, equals 1 over x plus 2, times it by both of the denominators, x minus 1, x plus 2, plus 4 over x minus 1, x plus 2, times it by both of the denominators, x minus 1, x plus 2. And the reason we're going to do this is that we're going to be able to cancel out, boom, 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 and on the last term we cancel out all of the parentheses. We're not going to be left with any denominators anymore. So be careful with your parentheses now. We have 2 times x plus 2 equals 1 times x minus 1, which is just x minus 1, plus 4. The only thing left over here. Everything else canceled. Let's distribute. 2x plus 4 equals x minus 1 plus 4. So 2x plus 4 equals x plus 3. And so when we subtract an x, we'll get x plus 4 equals 3. And when we subtract the 4, we'll get x equal to negative 1. All right? Now, we do need to check for what's called an extraneous solution. Remember, what you can't have in the denominator, you can't have a 0 in the denominator. So, what are our denominators? X minus 1 equals 0. I'm sorry, does not equal 0. And x plus 2 does not equal 0, right? This is our domain. So x cannot equal 1. X cannot equal negative 2. Is negative 1 equal to either of those things? It is not, so we're okay. This answer is just fine. So try problem 71. See if you can solve that rational equation. Okay, so now we're going to see an extraneous solution. We're going to solve it the same way. But when we check the answer at the end, something's going to go a little haywire. So we'll see how that works in a second. X minus 4. What are all the denominators? There's an x minus 4. There's an x plus 4. So that's what we need to multiply every term by. Equals 8 over x minus 4, x plus 4. Multiply it by both of the denominators, x minus 4, x plus 4. Cancel everywhere you can. What are we left with? X plus 4 times 1, which will just be x plus 4. On the left and on the right, 8 is the only thing left. When you minus 4, x equals 4. So that's our answer, but we need to check it. Remember that x minus 4 doesn't equal 0, and x plus 4 doesn't equal 0. So x cannot be 4. Uh-oh. We said x is 4, but x can't be 4. So what we have here is no solution. Is our final answer, because x equals 4 is what we call an extraneous solution. All right, it's a solution that worked when we did the algebra, but when we checked it, it didn't end up working when we plugged it back in. So try 61, see if you can find the extraneous solution, and then we'll move on. Okay, last objective. We've got 2 word problems to look at. Solve problems that can be modeled by linear equations. And that just means, how do we do these word problems? A couple sticky ones. We'll see if we can set them up. So, 5 steps in doing the applied problems, our word problems. First, we've got to read very carefully. Sometimes you got to read 2 or 3 times. Really pay attention to the question being asked, and really pay attention to what you're trying to solve for, right? What you're looking for. All right? If you can't determine realistic possibilities for the answer, this is important. Sometimes your answer, based on reading the question, you know it can't be negative, or you know it has to be smaller than 10, or something like that. It depends on the question, but if you can, figure out what your range of possibilities are. All right, step 2, let's assign a letter, a variable, for all of our different quantities. Okay? So we'll walk through doing that. We'll make a list of our known facts and translate them into mathematics. All right, so we want to change the word like the amount of widgets was equal to 50, and we can say W equals 50, something like that. Sometimes we need to draw a chart, sometimes we need to do a diagram, sometimes we'll do a drawing of some sort. All right, so then we'll solve the equation for the variable and answer the question using a complete sentence. Lastly, we need to check. Make sure it works. Check for those extraneous solutions. So let's walk through the steps here. A total of $24,000 is invested. Some of it's in stocks, some of it's in bonds. If the amount invested in bonds is half that invested in stocks, how much is invested in each category? All right, what are we looking for? We're looking for how much invested in stocks and how much in bonds, right? So next step, let's assign a variable to represent what we're looking for. So stocks, how about S is stocks? And how about B is bonds? All right, so we want variables for the things we're trying to solve for. All right, any unknown quantities in terms of this variable. And we'll combine that a little bit with step 3 to translate this into mathematical statements. So let's look at this. A total of 24,000 is, so that word is always means equals. 24,000 equals some stocks. We don't know how much, so that's S. And, the word and is a plus, some bonds. Right? And now the amount invested in bonds, so bonds, is equals half of whatever you invested in stocks. So 1/2 times stocks. We could write that as S over 2 as well. All right. So now we want to solve our equations for both sides. So let's start by getting one variable by itself here. Let's get S all by itself here. All right. To do that, we would minus the B. And so we could say that S equals 24,000 minus B, and then we're going to plug it into the other equation. So B equals 1/2 of 24,000 minus B. So we'll simplify. B equals half of 24,000 is 12,000 minus 1/2 B. We'll add 1/2 B to both sides to get the 12,000 by itself. And so let me rewrite this over here. 3/2, 1.5. B is equal to 12,000. And actually, better off if we write it as a fraction, 3 over 2. Because how do we get rid of a fraction? We multiply by the reciprocal. Sorry about that. Sometimes the smartboard brings what I've erased back. Let's see if it'll stay erased here. If not, I'll have to write it somewhere else. 3 over 2b. To get rid of the 3 over 2, we're going to multiply by 2 over 3. So 12,000, running out of space here, 12,000 times 2 all over 3. And we know, what's 12 times 2? That's 24. 24 divided by 3 is 8 with 3 zeros. That's how much you put into bonds. So now we know that 24,000 equals S plus 8,000. So now if we subtracted that 8,000, we would say that 16,000 is in stocks. All right, that's what we think is the answer. Let's go back and check to make sure that that works. Do they add up to 24,000? Yes. And is the bonds half as much as stocks? Yes, it is. So we know that we've got our answer. All right, so that was one example. Your turn. Try problem 95. There we go, last one. Ann grossed $560 in a week. I'm assuming that's what they're trying to say there. By working 48 hours, her employer pays time and a half for all hours worked in excess of 40 hours. Let's find her hourly wage. So, what are we solving for? We're solving for the wage that's hourly. So let's give ourselves some variables. How about W is wage? And how about H is hours, right? Hourly wage, we need two variables there. All right, so we know that $560 a week for 48 hours. So we know that her hours were 48. But there's actually one additional thing that we need here. We've got hours, and we also have overtime hours, right? So overtime hours, we might call that, O's not really a good one to use. How about we do V? And we have regular hours. Okay? And so we could use something like R. But we don't really need a variable here because we know what those hours are. We know that the regular hours was 40 and the overtime hours was 8. Were 8. All right, so now let's figure out what's going on here. Overtime pay, we know that that's going to be time and a half of whatever your normal wage is, right? And your normal wage, just W, is going to be at your regular hours. So we're just going to get paid a regular amount for that. Okay, so this is overtime. And this is regular. All right, let's see if we can put all of this together. We know that 48 hours adds up to $560. So 560 equals 1.5 times whatever her wage was, times how many hours? Times 8 hours. Plus her regular wage times 40 hours. So let's clean this up here. 1.5 times 8 is 12, plus 40. Clean it up again, we get 52. So 560 equals 52 times W. Let's divide both sides by 52. And so if we go into our calculator here, let's do 560. So one thing, just a tip on your calculator, if you're in the graphing calculator and want to get graphing screen and want to get back to the regular one, you can quit second mode. That'll take you right back to here. 560 divided by 52 is $10.77. Okay, $10.77. Let's see if that makes sense. That times 40 is $430. Okay. And then $10.76 times 8 times 1.5 is 129. If we add 129 plus 430.76, if we put those two things together, we get back to 559.88. Not quite to 560. What happened? We rounded right here, 1076 instead of this. Oh, I should have really put 1077, shouldn't I have? Right there. So that's what's happening there. Rounding, we lost a little bit, but we did get our answer. So she's making $10.77 an hour. All right, last one for you to try. Try problem 99. Make sure to make notes on anything you have a question about. We will definitely go over these in class, and good luck with all of those.